Hey everybody, happy Monday. It is Monday, the 21st of September 2020, and I am reporting in on this Monday to bring you a lesson regarding density. But before we start this lesson, I just want to let you know what the week's layout looks like. This Monday, of course, today we are going to be doing Density Part 1 PowerPoint notes and Castle Learning questions to follow. That link will be in your Microsoft Teams right after the link that you clicked on to see this video. Tuesday, we will be doing Density Part 2 PowerPoint notes and again some Castle Learning questions. You will see not a huge amount of questions for these Castle Learning assignments. Basically, there are 8 questions per assignment. I want to really focus on quality work over quantity, so I didn't want to hammer you down with too many questions. Do note, though, that these questions are going to be counted as classwork, not just participation grade, but actually classwork grade that will accumulate towards your final average for the quarter. So before actually attacking these questions, I would probably watch these PowerPoint videos, YouTube videos with the PowerPoint notes once or twice to make sure that you're confident so that when you go to do these Castle Learning questions that you do a good job. For Wednesday, we're going to be doing our density lab. This will be the first lab of the year. Thursday will be review of observation, inference, classification, and density. The review for the first 3, observation and inference, classification, they originally were going to be in the beginning of this video, but I figured I could condense all of these into a nice review on Thursday, and density, of course, as well. Density test will be on Friday, thus the reason for the review on Thursday. So I just wanted to let you know that well in advance. So here's the deal. Today's lesson is going to be about density. So let's kind of get rid of that and bring up our PowerPoint and let's get to it. So density is a very interesting thing because most students come into ninth grade knowing a bit about it. But one thing that I constantly hear about density is just um, basically the production of people just saying mass divided by volume, mass divided by volume. They know that formula, but they don't actually know the concept behind density. And I kind of want to change that for many of you today. I don't want you to just think, hey, density is that mass divided by volume, formula. What I really want you to think about is the concept of what density is. And density, even though it's defined as the amount of mass in a given area or the amount of mass in a volume or given volume, density is more related to how tightly or loosely packed molecules are in that given area. So if you look right here on the balance beam, right, you can see this balance beam is being weighed down because the object that has been placed on the right side of it has a very high density, whereas the object on the left side of it has got a low density. So what does density really mean? Well, if you look at these equal volumes, these equal cubes, both of these cubes have the same, they occupy the same amount of space, same volume. But when we look at the thing on the right, which is the high density, you can see that there is so many more molecules packed into that space versus the one on the left. Thus, this has the higher density. In essence, that makes it way more for its actual size, and that's why the balance beam is down on the right and up on the left. So again, think of density as how tightly or loosely packed molecules are in a given area. So that brings us up to, I'm going to show you a YouTube video that kind of shows you how scientists find the mass and the volume of substances or objects on Earth. And then, of course, once we can figure out mass and volume, like again, it's that simple equation that so many people come into ninth grade being able to recite. Now, just to give you a heads up before we watch this video, the equations box on the front cover of your reference tables is always there for you to use on any test, quiz. It's going to be given to you on the day of the Regents. But in case you do forget that very simple mass divided by volume formula that gives you density, it's always there, page 1. I copied and pasted that box right here into your notes, but you'll see it if you grab your reference tables. So without further ado, let's minimize this and jump right over to our density video. So here we go, a video inside of a video. So take a look. This is going to show you all about how we figure out mass and volume of common Earth substances to be able to calculate density.
How to calculate density. First, we must know what density is in order to calculate it. So, what is it? Simply put, density is the amount of a substance in a measured 3D space. We call that 3D space volume. Volume is usually measured in cubic centimeters or milliliters. What does volume have to do with density? Quite a bit, actually. Density is how much mass of a substance you can have in a volume. We notice different densities almost every day. I suspect you would be more willing to carry a block of styrofoam up a mountain than an equal volume of lead. You can have a large object with very little mass or the same size object with a large mass. The higher the mass per unit of volume, the higher the density. So if density is the amount of mass in a volume, then dividing the mass of a substance by its volume tells us how much mass is contained in 1 unit of volume. The official equation is density equals mass divided by volume. Let's see how this works with an experiment. To calculate the density, we need to know the mass and volume of our corn syrup. So let's first measure out the mass of our container, since we are only interested in the mass of the syrup. My beaker weighs 48 grams. Now I will measure out 20 milliliters of corn syrup. The scale gives us the total mass of corn syrup and the beaker. Time for some math. We subtract the mass of the beaker from the mass of the beaker containing corn syrup. We do not want the mass of the container in the calculation. So we subtract, and that gives us a difference of 27 grams. To calculate density, we take some of the mass of the syrup, which is 27 grams, and divide that by the volume of 20 milliliters. We do the math and we get a resulting density of 1.4 grams per milliliter, rounded to two significant figures. What that means, for every milliliter of volume, I have 1.4 grams of corn syrup. Let's do another calculation, this time using water. If you have a digital scale, the easy way to get the mass of an object minus the container is to use the tare function. Place the container on the scale and then press tare. Now add 20 milliliters of water to the measuring cup. This is our volume. The scale does the work and gives us the mass of water, and I have 19 grams. Now we do the calculation. We divide 19 grams by 20 milliliters, and that gives me a density of 0.95 grams per milliliter. That rounds to 1.0 grams per milliliter. As a side note, the density of water varies slightly with temperature. I get this figure as my scale is not precise to the 10,000th place. Now let's do one more example. Let's do peanut oil. We measure the mass, 18 grams, and we get a volume of 20 milliliters. Divide the mass of 18 grams by 20 milliliters, and we get a density of 0.9 grams per milliliter. Let's pour these different liquids into a glass and see how the different densities affect each other. The least dense substance flows on top, followed by the water and corn syrup at the bottom. The least dense substance atoms are unable to press through the denser substances below it. And that is density. And this is the boring voice. Thanks for watching.
So this very last image that you guys see here is kind of neat because when you take a look at this, you can see that they're pouring all three different of the liquids that they found the density for into one another. And what settles to the bottom, of course, is your most dense at 1.4, that's that corn syrup. Water, which has a density of 1.0 grams per milliliter, right in the middle. And of course, the least dense is going to be 0.9 grams per milliliter, and that's oil. So these things settle out into layers when actually poured together into one beaker because of their density difference. Always the least dense or the lower number is going to come to the top, and the most dense or the greatest number here for density is going to sink to the bottom. All right, so that video I thought was pretty neat. I thought it was helpful in being able to understand how to calculate density out and how to actually get your mass and volume of an object. The one thing that they did not do, though, that I wanted to kind of make sure that everybody was comfortable with is being able to calculate the density of an actual, like an actual concrete or solid object, which they did liquids, but they didn't do solids. So I kind of brought up two examples on practicing, making sure that you guys understand how to practice and actually find the density of solid objects versus liquid. So we are going to start here today. We have two examples. The first example is on the left here, right? We have a box right here. And then the second example that we'll be doing here is we'll be finding the density of this looks like a rock, right? So practice calculating density, examples 1 and example 2. So in the first picture on the left, we see a box, and they clearly say to us the mass is 200 grams. No weight necessary, they just gave us the mass. Now when I try to do this, like when I actually start to do density calculations, one of the things that I always want to make sure that I do is I'm keeping track of all the numbers and the information they're giving me. So I like to kind of write things down. So in this case, the mass equals 200 grams, right? Oh, 200 grams. And then I say to myself, okay, what was the volume in this? And the volume is not given to you in a very typical way. What they did is they gave you a length measurement, they gave you a width measurement, and they gave you a height measurement. So you got 3 measurements, a length, a width, and a height. And they actually want you to mathematically figure out the volume. And volume's figured out by taking the length, multiplying it by the width, and then multiplying that by the height. So you're actually expected to do 6 times 4 times 5. Now 6 times 5, I take the bigger numbers first. You can do it on a calculator, but 6 times 5 equals 30, and 30 times 4 equals 120. Again, I would always recommend checking your mental math on a calculator as you do this, because you don't want to get through all the steps of doing density, which is the not even a challenging part, but it's the labor intensive part of this, and get the question wrong because you just made an error with your simple math. So we got 120, and your units for this, as you see, we calculated cm, centimeters, 3 times. So it's going to be 120 centimeters cubed. Now, to find density, we all know it's a very simple formula at this point. All you have to do is divide these two numbers. So you do 200 grams divided by 120. So if I put my pen down, and I can kind of shrink this down a bit, minimize the screen just a tad here, I should be able to bring up my calculator. And again, if I check back, it was 200 divided by 120. So I'm going to put that in, 200 divided by 120. And once you get your calculation in, you could always round to the nearest tenth. And that would be rounding to just one place value to the right of the decimal. So this 6 tells this 6 to become a 7. So in the end, your density of this first object is going to be 1.7, and it's going to be grams per cubic centimeter. Again, 1.7 grams per cubic centimeter. That is going to be your answer in the end. Okay, so again, pretty straightforward stuff. Okay, nothing terribly difficult. So we're going to clear out this calculator. We're going to go back. Let's erase all this crazy writing we got in here, and then we're going to go to our second example. And you're going to see the second example. Again, it's finding the density of a solid object, not a liquid like we saw in the video. But the difference here is they don't get the volume by doing length times width times height. What you're seeing in this example, if I make this maximized again, what you're seeing is that you have a very irregular shaped object, and you can't put a ruler to this to get a length, width, and a height with any accuracy. So the first thing that I'm going to think to myself is, okay, when I'm looking at this, right, let me get my marker going again here. When I'm looking at this, all right, let me just make this a bit smaller, and I see this rock on the scale, my mass is pretty straightforward. Okay, so my mass equals 482.63 grams. And again, that was pretty straightforward. You just looked right on here. They gave you the mass. And then what happens is they can't do length times width times height of an irregular shaped object. So what they do is called the water displacement method. They take a graduated cylinder, they've placed some liquid inside of the graduated cylinder, and you can start at whatever level you want. They started at 600, right? So you got 600 milliliters in this graduated cylinder. And then we carefully kind of roll the rock into the graduated cylinder. And once that rock gets into the water, it displaces, which it moves the water upwards into the graduated cylinder to get a measurement now of 800. So we went from 600 milliliters to 800 milliliters. That is a difference of 200, which tells me that that rock took up space of volume, if you will, volume of 200 milliliters. Once you get these two numbers, it's the same thing, you just divide. So we're going to do 482.63 grams divided by 200 milliliters. So again, we're going to just go back to our calculator, 482.63 divided by 200. So let's go back. We're going to do 482.63 divided by 200. We hit equal and we get 2.41. If we round to the nearest tenth, that equals 2.4. Again, to the nearest tenth would be one digit to the right of the decimal place. So that one tells that 4 to stay, not to go up. So again, our answer for this one is going to be density equals 2.4, and that's grams per ml. Again, with our density units, the grams always comes first. The ml in this case comes second because that's what our units were. Over here, remember, it was the grams first, but with the cubic centimeters because we had length times width times height. Okay, so your units are going to be either one or the other, generally speaking, with density. So that should be pretty straightforward, which takes us to the very last part of our lesson, which is going to be called the density triangle. And the density triangle is a super, super good graphic organizer, if you will, that kind of helps us to understand what to do with particular density calculations. So let's maximize this a bit here. And I want you guys to take a look at this thing called the density triangle. And the density triangle is super helpful because it tells us what to do within density, mass, and volume questions when one of those three things is missing. So for instance, let's just get my drawing pen back up, right? You already know that if they're asking for density, it's mass divided by volume, right? So if the density went missing, and I cover up the density, you do mass divided by volume. And if I gave you, like we just practiced, a very simple mass divided by volume, I could tell you that the mass equals 250 grams and the volume equals, we'll make up a number like 25 cubic centimeters. And I say, okay, what's the density? You would do 250 divided by 25. In a calculator, 250 divided by 25 equals a density of 10 grams. That's a 0. 10 grams per cubic centimeter, right? Very straightforward. That's easy because you've been practicing that all along. However, there will be a CASEL learning question or two, and then a test question or two, and perhaps a Regents question or two, or a life question or two that asks you, just so that you know, to find something other than density. It may actually ask you to find something like the mass. So understand, right? If the mass goes missing and I get rid of mass, you got two things left. You got a density and a volume. And what are you supposed to do? But multiply those two numbers to find the mass. So here's a general question. They'll say, what's the mass of an object? If, and they'll give you a density, and they'll tell you, like, if the density is 2.8 grams per milliliter, and the volume is, they'll say something like, I'll give you the number 46 milliliters. So right here I got two numbers. I got 2.8 and I got 46. And I remember it's the mass which has gone missing. So if we go over here and again, we cross out the mass, you do density times volume. So again, you would go to our calculator, right? If I minimize this down just a bit, 2.8 times 46, clear this out, 2.8 times 46, and I would find out that my density, I'm sorry, what was missing again was my mass, right? So my mass was 128.8 grams. So again, that's pretty straightforward stuff. My mass equals 128.8 grams. Okay, now just to show you a final example and then we will be finished. I'll erase this down and we'll make one final example. So we did density, we had the mass just missing. Let's make a volume go missing in a question. So here we go. Get my pen back going. Okay, let's make the volume go missing. Get rid of the volume. Here's a question. Find the volume of an object. That's your question. That's what's missing. Find the volume of an object if, we'll say the density equals, and again, I'm just making these numbers up as we go, 8.1 grams per milliliter, and they'll tell you that, we'll just say that the mass equals 64.4 grams. So again, I got a number for density, I got a number for mass. It's the volume which is missing. We scribble out the volume in our density triangle. What do? Mass divided by density. So think about this. It's this number first, 64.4 divided by the density, 8.1. So you ready? Let me go over to here, clear out our calculator. We're doing 64.4 divided by 8.1, and you got it equals, and your answer is, now this 5 tells the 9 to go up, and this 9 would actually kick that 7 up to an 8. Your answer would actually round to 8.0. So we come back here, your volume equals 8.0, and that would be milliliters. Okay, guys, so the density the density triangle should help you with your calculations. I certainly would make sure that you got that kind of copied down into your notes, or at least a mental reference, because you will have some questions on your CASEL Learning, which is based on that, and hopefully that helps. Tomorrow we're going to pick up with the second half of this actual PowerPoint, which is important facts about density. We're not quite there yet. I want to give you some practice with these first couple of, well, these first concepts. And then, of course, once we're good with this, we move on to tomorrow. And then once we're good with tomorrow, we work on our lab. So please don't forget, once you're done with this video, that you are going to click onto your CASEL Learning. You will need to log in to get to your 8 questions. It is all about quality of work, not quantity. And do remember, you need to do a good job on those questions. I do believe I allowed 1 retake within that question. On CASEL Learning, you can retake for half credit. So hopefully you take advantage of that if you don't like how you did the first time. And those questions do count towards your average, so make sure you do a good job. And that will also be the way we take attendance. So just make sure you do it during your class time. All right, guys, have a great day. I will check in with you tomorrow. Hope you had a great weekend.